Now we can go to the next chapter, which is talking about one approach. It's called minimum complexity solution that tries to optimize the design at the different stages and starting at the macro level. The first thing that we do with this approach is to make sure that we all together, and again, when I'm saying all together, I'm talking about the business originator, I'm talking about engineering, but I'm talking about controlling, I'm talking about operations, I'm talking sorry, about purchasing. So all the stakeholders that are involved come together and make clear what are the main requirements. In that case, the key role will be from the business owner, the originator, that will need to describe why a certain requirement is a must-have. So here you see that there is a rating which is mandatory, which is regulatory, or even if it is not, it means some of these requirements might be nice to have, and the project team needs to know it because they will put under special scrutiny all these design features that are leading to requirements that are nice to have, because those eventually can be deleted if there is no clear business case. What do we do next? The next part, on the next page, please. We are looking at what is the initial Capex estimate. So we create a Capex breakdown, which looks like this. The concept is to have the Capex initial estimate divided by different physical assets you see in the rows, and different functions you see it in the columns. And functions might be the very key functions to value add, so those ones that are really responsible to deliver that product that the customer is looking for, which is clearly those processing units that are transforming our feedstock into what is our end product. And then we also see supporting functions like utilities, like infrastructure. We also see something which is related to optional products. If we have a breakdown like this, we can then define what are those functions that are consuming the most Capex for the least value. I put these three arrows from the bottom to highlight that actually we have 10% of the overall Capex is supplying utilities. The question often here is, do I need to have a power station inside my plant, or do I buy it? Or do I have a provider outside that is providing me energy and steam, so I don't need to invest myself? So these are those functions that you can eventually take out of your core project and buy it. So these are those ones where there is importance to have the most of the attention. If we go to the next page, forgive me for the bit of the complexity of this. This one, it's maybe the most important tool in the minimum technical design approach. We call it design alternative matrix. What it is, we take the preliminary design, the concept, the design that is available at that stage, and we break it into different categories and design choices. Just to make an example, I've highlighted the gray one. So we talk about utilities, and in the utilities there are energy, there is water. In the design choice regarding energy, we could ask ourselves, and we are here at the macro level, if the energy comes from a provider, or we produce our own, or we produce our own, but we also do steam together, so we do cogeneration. So in this matrix, it's very important, first of all, to start and highlight what is the baseline. and the baseline is connected by the orange line. So you see we have the baseline design, which has a feedstock mixture, which is an option 3. So behind that, there will be, of course, a more detailed description of what it is. The bottleneck step is the cracker. There is one phase at 20,000 kiloton per annum. There we have transportation of the final product with barge, and so on and so on. The interesting part of this matrix is then generated in a one-day all-together workshop, which is trying to define, along with what are the must-have project requirements, what is the minimum technical design. And this is what you can see following the black line. So the minimum technical design or minimum technical design could be a train of 2 times 10,000 kiloton per annum, transporting by rail, energy from providers, so we don't invest in a power plant, and so on. So the team during that workshop, which is following the definition of the must-have requirements, will highlight what are those characteristics that make this project the lowest capex possible. Minimum technical design means this is the bare bone solution. It doesn't mean that it will be the best one, but it's for sure the one that is not compressible. So it's that one that it's the minimum, the bare bone. The lowest capex for sure. There are some companies that really want to reduce the risk, and they also want to reduce the exposure to the banks, and therefore they really try to do the lowest capex solution. Other companies are really looking to the best net present value, because that's an investment that they will never do in the next 10 or 15 years, and so they want to do it best. So different situations might require a different approach, but with this approach here, we say we first start with minimum technical design. During the workshop and the weeks following, there might also be additional alternatives that are now highlighted with the green line, which are telling us what are those that are improving the NPV at best. How do we do this? If we go to the next page, we see the tool that we use in these cases. It's an NPV model that it's taking each of these design alternatives, and it's simulating what is the cash flow that this alternative will give. So if we say there is an alternative that it's adding a certain design, which means I'm spending some more money, but this money in the capex will let me have a better energy cost or labor cost, then I can see it in the different years, what is the cash flow and the NPV of that alternative seen today will be that one that will make this design alternative competing against other design alternatives to make sure that the only ones that are increasing the NPV are selected. So we are getting to the last pages of this, which is a summary. This page is trying to summarize what the minimum technical design approach is doing. So again, we are doing it several times along the development of the design. We do it as a kind of a pressure test of the design. So within the value assurance activities, this one, it's a short, very intense activity to pressure test the design at that stage. We start from an initial design, which you see the first bar of this graph, which is just a schematic to let you understand. The initial design, it's able to give a certain net present value, and this is the starting condition. So when we create the minimum design, we are eventually reducing the net present value because we will scream off all what it's not a must-have. So we will create a minimum design configuration which has probably a lower NPV as we started. But then, once we are at this stage, we will develop all the different design options that the team is able to generate in these brainstorming sessions. And some of them will reduce the NPV and therefore will be rejected. And some of them will add NPV to the minimum solution and therefore will be included to that. So that at the end, we come out with an improved design which is really made in order to increase the NPV. And not, as I said at the beginning, just to make sure that we fully use the original Capex budget that somebody fixed for us, and we often never know why was that target fixed like that.